Okay, here we are, chapter 9.1. This is on line plots, and we are trying to figure out how a line plot can help you find an average with the data given in fractions. So data is just a bunch of numbers, and we had students pour water into a bunch of beakers for an experiment, and all of their beakers had either 1/4 cup, 1/2 cup, or 3/4 cup. And it just kind of was random, and somebody went down and wrote down what each beaker had in it. And this is our list of numbers right here in this box. And you're talking about making a line plot. And what you kind of do, one of the ways to make a line plot is start with a line. I guess that makes sense. And this one has a mark for each of the different sized cups of water. So for instance, the smallest one is 1/4 cup. The middle one is 1/2 cup, and the larger one is 3/4 cup. And they have to have a title. So this one in your book says waters used in cup. Water used, not waters. Water used, and then it says in cups. That's a measurement that we're going to use as cups. Okay, if the total amount of water stayed the same, what would the average amount of water be in a beaker? So we're talking about average, and the average is this idea where you have some cups that only have 1/4, and some cups that have 1/2, and some that have 3/4. And we have to kind of figure out what the average is. And the average is kind of this look of what if you put a little bit out of the full ones into one of the nearly empty ones, and you kind of kept adding water back and forth with the same amount of water, and you didn't spill any until they all had exactly the same amount of water in. What would that be? And that's what an average is. It's kind of like when you level it all out, what's the number that you have? And they want us to count the number of cups for each amount. So we kind of have to go through and use our line plot and put some X's up here. And what I want to show you is kind of a way to keep track so you don't make a mistake. So you cross out a 1/4 and you put a little X right here. You cross out another 1/4, and that's another X. This is how you get going on a line plot. And cross out the 1/2, that goes over here. Cross out 3/4, that goes over here. And this is the way I would make the line plot. There might be some other ways. You might just count all of the 1/4 up and then put them up here. But sometimes you don't have all your data sitting in front of you. Sometimes you have to take it one piece at a time. Like each person calls you on the phone and they tell you what they got. And as you're listening to what they got, you're writing it down. And so that's what these little these little X's help you keep track without actually counting. And then when you're done, you can count them all and see. Hope that makes sense. Okay, so there was only one 1/2. Oh, there was two 1/2s, and that shows that this is the smallest one. So we can see now that we have 1, 2, 3, 4, 5, 6, 7 of those, 2 of those, and 3 of the 3/4. So this is our chart, and it's used to organize our data. So we have data, we're trying to find an average, and we use a chart. And this is a line plot. Okay, and that's what this is, the line plot, to organize our data. And then it tells us what to do for step 1. It says count the number of cups for each amount. And draw an X for the number of times each amount is recorded. Complete the line plot. That's the one we just completed. So for 1/4, there was 7. For 1/2, there were 2. And for 3/4, there were 3. We just already did that, actually. Step 2, find the total amount of water in all the beakers that contain 1/4 of a cup. So we have 7 of these. So we have 7 times 1/4, because there are 7 of them. So it happens 7 times, and that equals 7/4, which is equal to 1 3/4 cup. That was step 2. We do the same thing for the half cups. Now there are 2 of them, so it's 2 times 1/2, which ends up being 2 halves, which is 1 cup. And then we do it a third time for the 3/4. That would be, there's 3 of them, times 3/4, and that equals 9/4, which is 2 1/4. Correct? Good. So we have all of those. And step 5 is to find the total amount of water, which means you're going to add 1 3/4 plus 1 plus 2 1/4. So I'm kind of running out of room here, but I think I can squeeze it in. If I add up my 3/4 and my 1/4 cup, that equals 1 whole cup. And if I add my already whole cups, 2 plus 1 plus 1, that's 4 cups. And I have to combine them, so it's not 41 cups. That wouldn't make any sense. But I have 4 cups here, and when I add 3/4 and 1/4, that gives me 4/4, which is 1 more cup. So I really have 5 cups. So I have 5 cups, and now I have to figure out what the average is. See, we started out with this idea of finding what the average is. And so that's, for instance, if we had the exact same amount of water in all the cups, how much would it be? And that's what the average means. Well, how many different beakers did we have? We had 7 here, 2 here, and 3 here, which means that we had 12 beakers. And so we have to use a division problem to figure out how much water is in each cup. So I have 5 cups of water, and I divide that by 12 beakers. And that becomes a fraction, 5/12. See, the division problem is the same as a fraction. They always are. They can always be written as a fraction, and a fraction can always be written as a division problem. And we might be able to simplify sometimes. In this case, we can't. This is already simple. 5/12 would be in each cup, or in each beaker. Okay, 5/12 is a little bit less than a half a cup. I want you to think about that. If we had 6/12, that would be equal to 1/2 cup. 5/12 is just a little bit less. So some of our cups only had 1/4 cup, but some of them had 3/4 cup, which is more than a half. And a few of them had exactly half. And when you add them all up and divide, you end up with 5/12 in each beaker. So pretty cool. Okay, they do a try this on the next page, 370. And they want you to think about a different way to do this. We had 7 beakers that we multiplied and had 1/4 cup each. And they want us to group that and then add the group that included the 2 beakers that had 1/2 cup each. So it looks like that, 7 times 1/4, we just did this on the other page, plus 2 times 1/2. And we're also going to add all the beakers that had 3/4. So there was 3 times 3/4 of a cup. And then they say, well, we take this total and we divide by 12. And because of order of operations, if I write it like this, it looks like just this number should be divided by 12. So I have to add a parenthesis, another parenthesis. This is called a bracket. I add a bracket that shows that I have to do all of the addition problems first. If I didn't do it that way, I would get a wrong answer. We have to do all of these addition problems first. We add them all up, and then we divide by 12. But first, before we add them, we have to do a multiplication problem on each one of them. We already know what these answers are, so I'm going to probably kind of squeeze through pretty quickly. I can't decide what color I want to use. 7 times 1/4 was 7/4. Plus 2 times 1/2 was 2/2. Well, we could just write this as 4/4, okay, instead of 2/2. Because if we keep our denominators the same, that might make our life easier. 3 times 3/4 was 9/4. And then we keep our parentheses here, and we divide by 12. And then we move down and we do the next step. 7/4 plus 4/4 plus 9/4 is equal to 7, 8, 9, 10, 11, plus 9 is 20/4. That's what I got by adding these together, divided by 12. And I can actually simplify 20/4 pretty easily. 20/4 is the same as 5 divided by 12. And I think you might remember that that is actually what we got for our answer on the previous page that we were looking at. 5/12 was our answer. 5 divided by 12 is 5/12. If you look back, you'll see how that works. That's basically the way to do everything on this assignment. We'll talk about it a little bit in class, but give it a shot and have some fun.